Okay, still on schedule. So let me introduce the first speaker, Sebastian. Sebastian started his journey with programming in CERN, where he falls in love with both Python and teaching. And I think that the teaching part is very visible during the recent time. So today, Sebastian will teach us about the Python versions and dependencies, and the microphone goes to him. And just one more thing, remember about the virtual applause to encourage Sebastian. And here we go.
Hi, my name is Sebastian Witowski, and I'm a Python consultant, freelancer, and trainer. As part of my job, I join different teams and I work on different projects. And as I work on those projects, I notice that they often suffer from two problems. They are either over-engineered or oversimplified. The over-engineered ones involve jumping on every shiny new tool that people find on the first page of Hacker News. And then everyone gets excited because it's fun to work with something brand new. What is not fun is when this tool gets deprecated. Maybe the creator got bored and stopped working on it. So now you have to either fork it and keep it up to date yourself, or you have to replace it. On the other hand, we have projects that are still stuck in the 90s. Some people think that because it was fine to manage everything using bash scripts back then it's fine to keep using bash scripts today. It's fun if you're a hardcore Linux user and you love writing bash scripts, but to be honest, when was the last time you wrote one? Okay, writing them from scratch is not that bad. Maintaining a bash script that someone else wrote, it's much worse. And I don't mean that bash scripts are bad, they can be actually pretty great for simple things. But you should not use bash scripts for every possible thing in your project. So neither of those situations is good. So I've decided to make this presentation. I want to show you some of my personal recommendations, but also some alternatives that you might like. So this is the stuff that I recommend when I go to work with a client. What we are going to talk about. First, I will show you how to install different Python versions on your computer using a tool called pyenv. Then I will talk about Python dependencies. I will explain you what are virtual environments, how they work, and why you need them if you work on multiple Python projects. I will also compare the built-in venv module with some external tools like virtualenvwrapper. Next, we have a short chapter where I will talk about a tool called pipx. This is a great tool if you want to install Python package globally, but at the same time, you want to isolate it from other packages on your computer. And finally, I will talk about some dependency and project management tools like Pipenv and Poetry, and I will show you a much simpler alternative for dependency pinning called pip-tools. First, let's talk about installing Python on your computer. Depending on your operating system, your computer might already come with some version of Python. If you're using macOS, then it comes with Python 2.7. If you're using Linux, then the Python version depends on which distribution you are using. In Ubuntu 20.4, it's Python 3.8. In Debian 10, it's still Python 2.7. And if you're using Windows, then you don't have any version of Python installed. So let's talk about the scenario where your operating system comes with a Python version. This Python version already installed on your computer is often called System Python. And no matter what System Python version you have, I strongly suggest that you don't use it. In many cases, as we saw, for example, with macOS, it's terribly outdated. Python 2.7 is no longer officially supported by the core developers, and hopefully you are no longer using it since a long time. You might be tempted to upgrade the System Python version to Python 3, but probably you have some programs on your computer that require Python 2.7. You would be surprised how many programs or even parts of the operating system still require Python 2.7, at least on macOS. If you update System Python, those programs will stop working. So if you change the Python version that comes pre-installed on your operating system, you risk that your computer will stop working at all. And that is not fun. I have done that in the past when I didn't know much about programming and operating systems, and I had to reinstall the whole operating system from scratch. So my advice here is leave the System Python alone and pretend that it doesn't exist. So no matter what operating system you have, you will need to install Python. There are many different ways to do this. You can go to the python.org website and download the installer for your operating system. You can use a package manager like Homebrew on Mac or apt-get on Linux. And you can even compile Python from the source files. However, my favorite way of installing Python that I've been using since a few years is to use a tool called pyenv. Pyenv is a tool for managing Python versions. You can use it to install new Python version and to quickly switch between the existing ones. It might not be a big deal if you only use one Python version all the time, but if you're working with multiple Python projects that require multiple Python versions, this tool is extremely useful. While pyenv will work for macOS and Linux, if you're using Windows, check out pyenv-win. It's a port of pyenv for Windows. It might not have all the features that standard pyenv has, but it has the essential ones. You can install pyenv with Homebrew, you can clone it with Git and then manually set up a few things, or you can use the pyenv installer tool. This last option requires you to just run one command in your terminal. It will install pyenv and some additional plugins that make pyenv even more useful. Once you have pyenv installed, you can use it to install new Python version. To see a list of which versions you can install, run pyenv install -- list. You will see a huge list of available Python installations. At the top, we have the standard CPython versions. But apart from that, we can see that we also have Anaconda, Miniconda, and PyPy versions. So all those different types of Python can be installed with pyenv. If you ever wanted to try PyPy, now you can easily do this. Once you select a version from this list, type pyenv install and a version number. Then you usually have to wait a few minutes for the installation to finish. If you have all the additional dependencies like OpenSSL already installed, this installation process might go faster. Once it's done, you can run pyenv versions to see if this new version was installed correctly. We can see it here on the list, so that means we are all set. Now we have to tell pyenv to use that version. And for that, we have to choose one of 3 different levels at which we want to change the Python version, either global, local, or shell. pyenv global is the most common usage of pyenv. It changes the Python version globally on your computer. So running pyenv global 3.9.0 is equivalent to installing a different Python version on your computer. Pyenv local will set a specific Python version for the current folder and all the subfolders. You would commonly use this command if you're working on different projects and each of them is using different Python version. For example, let's say you have 2 projects, project A that is using Python 3.9 and project B that is using Python 3.6. Instead of changing the global Python version back and forth, you can just call pyenv local 3.9 in one folder and pyenv local 3.6 in another folder, and you are all set. Pyenv will automatically change Python version when you go inside either of those folders. And finally, we have pyenv shell that changes the Python version for your current shell session. You might want to use this in a situation where you want to temporarily change which Python version you are using. For example, maybe you want to run some code under Python 2. So you run pyenv shell 2.7, and now you can use Python 2. But once you open a new session in your terminal, you are back to using the previous version of Python. Now let's talk about Python packages. Installing new packages in Python is quite easy. All you have to do is to run pip install and a package name, and this will download and install this package for you. However, pip has one big problem. Whenever you ask it to install a specific version of a Python package, it will uninstall the previous version from your computer and install the one that you asked for. Let me show you an example. Let's say you are a web developer and you want to build a Django website. You start by installing the latest version of Django with pip install Django, and that installs Django 3. Everything works great. You build an awesome website, and it's so good that soon you get a first customer coming to you and asking to work on their Django website. As it usually happens, they are not using the latest version of Django, so their website is still running on Django 2.2. So you install that specific version of Django by saying pip install Django equals 2.2. Pip does what you asked for, and after a few seconds, you start working on your client's website using Django 2.2. So far, so good. But later that day, you discover a bug on your personal website, the one that you created with Django 3. You quickly fix the code, but when you want to test it that it's working correctly, you get an error message saying Django 3 is not installed. I mean, we just installed it like a few days ago. Where did it go? Well, when we told pip to install Django 2.2, pip first checked if we already have Django installed. And we did, but it was not version 2.2. So pip uninstalled this version and installed the correct one. We just ran into a problem with dependencies management. We have this problem because pip installs Python packages in the site packages folder and puts each package in a separate folder named after that package. So Django 3 is placed inside site packages/Django. But when you want to install Django 2, it will also be placed in the site packages/Django. So pip has to first remove what's inside the Django folder and then install a different version of Django. If you only work on one Python project on your computer, then you are probably not affected by this problem. But sooner or later, you'll need to install a different version of the same package, and you are going to run into issues with pip uninstalling some previous dependencies. The problem with pip is that it installs all the packages in the same folder. So how about we tell pip to temporarily install packages in a different folder, and then we tell our Python interpreter to use that folder instead. And that's exactly what virtual environment does. Virtual environment is a folder that contains a Python installation and any additional packages that you install. When you activate a virtual environment, two things happen. First, you tell pip to install any new package into this new folder, and then you tell Python interpreter to use packages from that folder. Now, if we try to install some Python packages, pip won't uninstall the previous versions from your computer because it's no longer using the global site packages. It's using the site packages from this specific virtual environment. Let's see how we can use a virtual environment. First, we need to create one. Python has a built-in module called venv to manage virtual environment, so we don't even have to install anything. We create a new virtual environment with Python -m venv and then the name of the virtual environment. This creates a folder called .venv in the current directory. .venv or venv are both a common convention for naming the virtual environment folder. This makes it obvious that whatever is inside this folder is related with a virtual environment. But it has another benefit. Some Python editors like PyCharm or VS Code will recognize this folder as a virtual environment, and they will automatically start using it in your projects. To use a virtual environment, we have to activate it. Inside our venv folder, there is a bin directory, and there we have activate script. Since it's a bash script, we have to run it with the source command. Once you activate it, you should see a difference in your terminal prompt. It should now display the name of the virtual environment in parentheses. That way we know that we are using a virtual environment. Now we do everything that we would do normally when building a Python project. If we install a package with pip, it will be installed inside this virtual environment. If we run a Python script, we will have access to Python packages from that virtual environment. And finally, to stop using a virtual environment, you just need to run the activate command. When you call deactivate, it will revert all the changes that activate command did. So you'll go back to using the global Python version and the global pip packages. A typical workflow with virtual environment involves creating one virtual environment for each of your projects. So if we are working on two Django projects, you first create one virtual environment, you activate it, you install Django 3, and you start coding. Then you create another virtual environment for Django 2.2, you activate it, you install Django 2.2, and you start using it. venv module is perfectly fine for managing virtual environments. But I want to show you another tool that I have been using for a very long time. It's called virtualenvwrapper, and it comes with a lot of cool features that makes working with virtual environments much easier. You can install it with pip, and it works on Linux and macOS. For Windows, you can check out the virtualenvwrapper win. Virtualenvwrapper stores all virtual environments inside .virtualenv folder in your home directory. And this provides you with some convenient methods for managing virtual environments. You can create a new virtual environment using the mkvirtualenv command, for example, mkvirtualenv Django to app. The difference between venv module and virtualenvwrapper is that when you use virtualenvwrapper, it doesn't matter in which folder you run this command. Your virtual environment will be created inside the .venv folder in your home directory. On the other hand, if you run python-m-venv, this will create a virtual environment in your current directory. Now, if you want to activate a virtual environment, you just have to call work on and the name of the environment. For example, work on Django to app. Again, you can call this command from any folder on your computer. And if you forget the name of an environment, you can get a list of all the existing ones by running ls virtualenv. With venv, it's impossible to get a list of existing virtual environments because venv doesn't keep a track of them. With virtualenvwrapper, since all virtual environments are stored in one folder, you can easily get that list. And then finally, to remove a virtual environment, just run rm virtualenv and the name of the environment. For example, rm virtualenv Django to app. So which one should you use? Well, it's up to you. I'm using virtualenvwrapper because it's much more convenient when I don't have to remember in which folder I placed which virtual environment. But venv is much easier to start with. So it's very common to start using it at the beginning. And when you feel more comfortable using environments, then you can use a different tool. All right, so we solved the problem of how to separate dependencies in our project. However, there are some Python packages that you probably want to use globally on your computer. For example, the code formatter black, the code linter flake 8, or even the virtualenvwrapper tool that we just saw. We want to use those Python packages across all our projects, or even when we are outside of a project. For example, we saw that we can use virtualenvwrapper to create virtual environment before we start working on a project. But if two different tools require different versions of the same dependency, they won't work together. You will get into a situation where installing one tool will uninstall dependencies of another tool, so this other tool will basically stop working. We could install each of those tools into a separate virtual environment, but it's a lot of hassle to use it like that. Each time you would have to activate that virtual environment first, and then you would have to remember to deactivate it. I mean, you can do this, but it's a lot of typing and generally it's a waste of time. This problem can be solved with a tool called pipx. Pipx installs Python packages in separate environments, but at the same time, those packages act as if they were installed globally. You don't even have to activate any virtual environment to use them. Let's see pipx in action. Let's say I want to use black to format some Python code. First, I run pipx install black, and after a few seconds, I get a success message. Now I can use black as if it was installed with pip. It doesn't matter if I'm inside a virtual environment or not. I will always use this global black package. I don't have to activate anything. I just run the same commands as I would run if I used pip. And if I want to install a different version of black inside my virtual environment, I can do this. This black from a virtual environment will take precedence over the global black, and it will be used as long as you are inside this virtual environment. What else can I do with pipx? Well, we can list all the installed packages to see what commands they offer. We can uninstall a package, and this will also clean up its virtual environment. We can upgrade all packages at once if we want to use the latest versions. And a very useful command is called inject. It will install a pip package inside the virtual environment of another package. We can do this, for example, to install some PyTest plugins. See, PyTest plugins have to be installed in the same virtual environment as PyTest to make them work together. If you install PyTest in one virtual environment and PyTest coverage in another one, they don't know about each other. So we have to run pip inject, then we have to specify the name of the existing tool, so in our case, PyTest, and then we specify the name of the pip package that we want to install inside this environment. In this case, PyTest Conf, which is a plugin to generate coverage reports for your PyTest tests. Okay, so we have all those tools set up and we are ready to work on our Python project. We are probably going to use some additional Python packages, so we have to decide how we are going to manage them. One way is to manually add names of packages to a requirements.txt file. Then you pass this file to pip by running pip install -r requirements.txt, and pip will install packages from this file. But there is a problem with this approach. If you don't specify versions of each package, pip will install the latest one. That means that if the new version of a package is released and you deploy your code to production server, pip will use that new version. And if your code can't work with this new version, well, now your website is down. It doesn't matter that it worked fine yesterday, today it's broken and you have to quickly figure out how to fix it. To fix this problem, we have to pin dependencies. We have to pin versions of our dependencies. So we don't say in the requirements file that we want to install Django. We say that we want to install Django that is at least version 2.2, but less than version 3, because we know that we still don't support Django 3. So always make sure to pin the dependencies of your packages. But here's the tricky part. You also need to pin the third-party packages, so the dependencies of your dependencies. Otherwise, there is a chance that, for example, Django depends on some other package, and when that package gets updated, Django will break. So we should not only pin versions of our dependencies, but we should also pin any third-party package that our dependencies are using. That sounds like a lot of work, but at least that way we can be sure that we have the exact same packages installed on our production servers as we have installed and tested during the development. But we are not done yet. We need to apply the security patches and we need to update our dependencies from time to time. So that means that we should regularly change which versions are pinned in our requirements.txt file. And that is a lot of work. I mean, it's too boring to do this by hand. So that's why tools like Pipenv or Poetry were created. They take a list of packages that you want to use in your project, and they will resolve and pin all the dependencies for you. Later, when you want to update your packages, you just run the update command, and they will update and pin new versions. Both Poetry and Pipenv are great tools, and they are the most popular dependency management tools among Python programmers. And Poetry has also some additional commands that makes publishing packages on PyPI much easier. But do we really need them? When you decide to use a tool like Pipenv or Poetry, you introduce yet another dependency to your project. What if there is a bug? They might stop working and you won't be able to install or update dependencies in your project until it gets fixed. Sounds unlikely? Well, between November 2018 and April 2020, there was no new release of pipenv. So people had to install it directly from GitHub to get the latest bug fixes. And that sounds pretty inconvenient for a tool that is supposed to make my life more convenient. What if this tool gets discontinued? You'll have to spend time and switch to a different tool. And both pipenv and Poetry use a custom file format to store the pinned versions of your dependencies. So you'll have to pin your dependencies from scratch, and that might introduce some problems. And do you really need a tool that lets you publish packages on PyPI if you're not even building a PyPI package? I mean, don't get me wrong. I'm grateful that tools like Pipenv and Poetry exist, especially since they are both open source projects, so people put their personal time to work on them. I've used Poetry on some personal projects and it was fun to use. You add new dependency with just a simple command, a new virtual environment is automatically created and activated for you, and publishing a package to PyPI was actually incredibly easy, so I'll probably use it next time I will work on a Python package. But I would never recommend using one of those tools to my clients unless their team is already using them. That's because you can manage your dependencies perfectly fine with a much simpler tool. The tool that I'm using in most of my commercial projects is use pip-tools. It's actually a combination of two tools. One is called pip-compile and another one called pip-sync. Pip-compile is the important one, so let's talk about this one first. With pip-compile, you specify a list of dependencies for your project, and it pins all the dependencies for you, including the third-party ones. Usually, the input file is a file with some dependencies pinned, but not all of them. For example, if you have some development dependencies like PyTest for testing, it's common to use the latest possible version. Let's see an example. Let's use a simple requirements.in file with just two packages. I want to use Django, but it has to be at least version 2.2 and less than version 3. And please disregard this mistake in the requirements.in. And then I want to use PyTest, but I want to use the latest version. So if we take this file with just two dependencies and we run it through pip-compile, we'll get a new file called requirements.txt, this time with all the dependencies of Django and PyTest and their sub-dependencies pinned. So, and every single dependency is pinned to the most specific version that is now available. And in addition to that, each package has a comment, so you can see where does it come from. We can see that PyTest comes from the requirements.in file, packaging library comes from PyTest, and finally pyparsing comes from the packaging library. So pip-tools has pinned all the possible dependencies. And if two different packages require the same dependency, like here the import lib metadata is required by pluggy and PyTest, pip-tools will try to find a version that satisfies both requirements. If it can't find such a version, it will report an error. And that's it. Now take this requirements.txt file and tell pip to use it. That's the requirements file that you will use on your production server, and you will use the same requirements file to run tests. And if in the future you see that a new version of Django was released, you can simply rerun pip-compile command and it will create a new set of dependencies. It's a good idea to make pip-compile part of your continuous integration pipeline. That way, your dependencies will be updated, but at the same time, your tests will be run on those new dependencies so you can see if something breaks. And if something breaks, let's say the latest version of Django has a bug, you can go back to the requirements.in file and pin Django version. That way, you won't use the latest version until you notice that this bug was fixed. This probably won't happen often, especially for popular packages like Django, but smaller Python packages can sometimes have bugs in the latest version, so keep that in mind. pip-tools comes with another command called pip-sync. You can use it to reinstall all packages using the latest requirements.in file. This tool is mostly for convenience. So instead of uninstalling all the dependencies and installing them again, you can just run one command. It can save you a bit of typing. So that's how you can use pip-tools to pin your dependencies. You still have to create virtual environments to install those dependencies, and you still have to remember to activate it, which is something that pipenv or Poetry would do automatically for you. But at least you are independent from yet another tool. If pip-tools breaks and you can't use it, you still have the requirements.txt file with pinned dependencies that you can pass to pip, so you are fine. You are not stuck with some custom format that pip can't use. And if you need to switch to a different tool, you just search for yet another tool that can pin your dependencies, or you just run pip freeze to do this by hand. So that's a comparison that you should consider when you start a new Python project. And that brings me to the end of my presentation. So let's quickly summarize what we saw. First, use pyenv to install new Python versions. Once you set it up, it's really painless to install new Python versions and switch between them. Then use virtual environments when you work on different projects and you want to isolate dependencies between them. Always make sure to create a separate virtual environment for each of your projects. And remember that Python comes with the venv module built in, but if you prefer an external tool, the virtualenvwrapper is a very good choice. Finally, if you want to install some tools globally, you can use pip outside of a virtual environment, but you risk that if there is a version conflict, they won't work together. So a much better tool is to use pipx that will install each package in a separate virtual environment. But for you, there won't be any difference in how you use them. And if you're looking for a tool to manage your projects, Pipenv and Poetry are both very popular choices. But if all you need is a tool for resolving dependency versions and pinning them, then there are better tools. PipTools is a great little package that can pin your dependencies and return a file format that you can use with pip. And even though this is the end of my talk, I realize I only scratched the surface of how to efficiently build Python projects. So if you enjoyed this talk and you want to learn more, I'm working on an online course called Modern Python Projects. It talks about the same topics that I covered in this talk, but in more details. Plus, it also talks about things like writing tests, documentation, or setting up continuous integration. It has examples of how to build a PyPI package or a CLI tool, and how to deploy a Python application. And there is even a chapter how to set up a VS Code for Python development. So it really covers the full spectrum of how to build a Python project, from the moment that you sit down in front of your brand new computer with nothing installed, all the way up to deploying your application. You can check it out at modernpythonprojects.com for more details, and I also have some free materials there. And if you're interested, you can join the mailing list to get a notification when the course is ready, and you'll also get a launch discount. And that sales pitch was the last thing that I have for you today. I hope you enjoyed my talk, and I think we now have time for some questions.
All right, so just a small reminder that you can ask questions to the presentation on any platform that you like, so either on Facebook, on YouTube, or on a Slack channel. We are reading all of them. So far, we have one question. Have you heard about Pew? That's a question from Gwynblade. It's a replacement for virtualenvwrapper, but does things different.
Have I heard about what's the name of this package?
Pew. P-I-W.
No idea. First time I hear about it.
All right. We have another question from Tomasz. If we set global Python version with pyenv, the system will still work? I mean, you said sometimes it depends on specific version of Python.
Yeah, so the thing is that when you install pyenv, it will prepend a path to your, prepend a folder to your path environment variable. So it's not modifying any Python that you have on your computer already. It's just modifying the path environment variable. So when you type Python command, it's going to first use this Python command from the pyenv. So if you mess up something with pyenv and you want to go back to the global Python version in your computer, all you have to do is just remove pyenv from your computer and modify the path environment back.
All right, you can still ask questions. Let's give a minute or two. In the meantime, I have a question. I'm also a huge fan of the stack that you've presented. I note that there is a slightly, let's say, competitive stack with local Docker images. What do you think about that?
What do you mean by local Docker images? Like developing everything in Docker?
Developing in Docker.
I mean, I use Docker in a lot of projects, but for like simple things, I would definitely use Docker for projects. So like I don't want to mess with like Postgres or with Redis on my computer. I just want to use Docker. So in that regard, I definitely support it. But for like working on simple Python scripts and stuff like that, I still like to use my computer because I don't want to spin up a Docker machine to actually test something with Python 2.7 or whatever. So I support both ways.
All right, we have another question, this time from Arthur. What are the other tools that you didn't have time to get into but would be worth mentioning?
Regarding what I already said, so for like Python management, dependency management, and pipx, that's all. But like the other tools are related to different parts. So in this course, I talk about PyTest, how to use PyTest, how to use things. So basically, different tools for different things, not related to what I just said, but like different tools for different tasks. Does that answer Arthur's question? Okay.
All right. Another question from Janek. What is the advantage of storing virtual envs in one directory in home versus having single .venv inside project folder? It feels like venv.venv belongs to the project for which it was created.
So those are two different approaches, and none of them is good or bad. As I said, when you use virtualenvwrapper, it stores everything in one folder. So that way you can list all your virtual environments, you can activate them. For example, I have like one test virtual environment where I just install all pip packages that I currently need. This is just a like trash can for different packages. And when I need to test it, I activate it. But I understand that for some people, it's more convenient to use the venv because, well, when you open a folder in PyCharm, it's automatically detecting this virtual environment. It's using pip packages, so it saves you a bit of setup, but at the same time, you have to remember in which folder you created which virtual environment. So pros and cons for both.
Okay, thank you. Let's wait for one more additional minute. Oh yeah, there is one more question, two more questions. So another question from Tomasz. I saw this package called virtualenv. What's the difference between this kind built in Python venv tool?
That's a very good question. And I think virtualenvwrapper is a wrapper on top of virtualenv, but from the top of my head, and I don't know what virtualenv actually does. I think it might have been the virtualenv management package before Python 3.4 when we got the venv built in, but I don't remember. So honestly, I haven't seen the virtualenv package in a long time, so I don't remember what it does.
All right, thank you. If you have, Tomasz, any further questions, feel free to ask them on YouTube. In the meantime, one more question from Celine. Does it check security vulnerabilities in dependencies, etc.?
I don't think so. There might be a plugin for pyenv because when you install it, it adds a lot of plugins, and each time I install it on a different computer, it installs more plugins. So there might be one of those. But for checking security vulnerabilities, I would use some different static analysis tools. There is Bandit, there is Prospector, and one of them I remember checks the security vulnerabilities. I don't remember which one.
Let me just add to that nice tool that works on top of your GitHub project. I think it works in a different way as well, is Dependabot, which just creates pull requests with updates to the project.
Yeah, that's a good point.
All right. Waiting for some final questions. Would there be any or not? All right, so I guess that would be it. Once again, thank you for your talk, Sebastian. I wanted to remind everybody that a virtual applause is much appreciated. Sebastian would definitely scroll through the YouTube and Facebook comments and take a look when they appeared on the timeline. And we will be taking a 5-minute break now to set up things. And in 5 minutes, we will start with another talk from Celine. So grab a beer, grab a drink if you're not drinking beer, and let's join back in 5 minutes.